In this video, we're going to talk about writing formulas for ionic compounds. Previously, we discussed how to determine charge. Now, when we're writing chemical formulas for ionic, the goal is to make sure we have a neutral compound. So that means we need just as many positives as we have negatives. So for this example, you're going to start off by figuring out charge. Lithium is in group 1, so that means it has a +1 charge. Fluorine is over in group 7, so that's a -1 charge. So we have a positive ion and a negative ion. So one of each balances out our negative and a positive. So we need one lithium and one fluorine ion. Calcium is in group 2, so it's a +2 charge. Chlorine is over in group 7, so it's a -1 charge. So one calcium has two positives stuck on it. And if I have only one chlorine ion, that's one negative. So here I don't have a balance yet. So I'm going to have to add in a second chlorine ion. Now I have equal numbers of positive and negatives. So that's one calcium. I've got one ion there. And then two chlorine ions, so CaCl2. The other way that the book and notes talk about doing this is you can cross. So if I have lithium +1, fluorine -1, you take your charge and it becomes the subscript of the other. So Li1F1. Here we would have calcium, that's a +2, chlorine, that's a -1. So that 2 becomes the subscript on chlorine, 1 becomes the subscript on calcium, and you end up with that Ca1Cl2. Either way works. Potassium's group 1, +1 charge. Sulfur is group 6, so it's a -2. So now I have a single positive and a double negative. So I'm going to need two of those singles positives. So that's going to be K2 for every one sulfur ion. Strontium is in group 2, so it's a +2 charge. Phosphorus is in group 5, so it's a -3. So 2 and 3 combination is one that's a little bit trickier to think about. We'll draw it out here. Here's two positives. So that's a single strontium ion. Single phosphorus ion is 3 negatives, so that's not balanced. So I throw in another strontium. Now I'm still not balanced. Throw in another phosphorus. Still not balanced. Throw in another strontium. Now I'm balanced. 6 pluses and 6 minuses. So that comes from 3 SRs and 2 phosphorus ions. Again, you can see that the charge swap works here. So 2 becomes the subscript on phosphorus, 3 becomes the subscript on strontium. Whatever method works will get you to the right answer. So far, all we've talked about are ions with fixed charge, which we can determine based on valence electrons and group number. Earlier, we skipped that transition metals section, that middle part of the periodic table. That's because there's not a set pattern. There's not group number connected to charge. Some ions can have more than one charge. If you see here in this partial table, iron, for example, could be +2 or +3. There are some others. Copper could be +2, +1. Gold +1, +3. So these you can't tell just by looking at the periodic table. So somehow you'd have to be given more information. Either a partial table like this. If you already have a formula, you can work your way backwards to get charge. If you have a name, you can get charge, and we'll talk more about those later. For now, you've got this table to work with. So if we look chromium, the only option is +3. Chlorine ions, we're back to looking at group number. It's group 7, which is a -1 charge. So again, same goal. We want neutral overall. So if I have one chromium, I'm going to need 3 of the chlorine ions. Nickel, only option is +2. Oxygen is in group 6, so it's -2. So +2, -2, I need just one of each. So NiO. Here's some examples. Iron, you can see, has different charge options. But notice this Roman numeral here, and this is a little bit of a preview for naming. The Roman numeral tells you the charge of the transition metal. So this is iron with a +2 charge. Then nitrogen's in group 5, so that's going to be a -3. So that means we're going to need 3 irons and 2 nitrogen ions. Copper 1 means we've got copper with a +1 charge. Bromine is in group 7, so it's -1. So we're going to need 1 copper and 1 bromine ion. The last type of ions that we're going to talk about are the polyatomic ions. If we break apart our word, the prefix poly stands for many, or in this case, more than one. And then you've got the word atom in there. So these are ions that are made up of more than one atom. If we look at the table, nitrite is a polyatomic ion. It has 1 nitrogen atom, 2 oxygen atoms, and together that makes 1 ion with a -1 charge. Another example, ammonium has 1 nitrogen and 4 hydrogens, and that together forms 1 ion with a +1 charge. So for writing formulas, it's really the same process as we saw with the monatomic ions before. The key difference is if you have more than one polyatomic ion, you need to put it in parentheses and say how many you have on the outside. So let's look at an example. Calcium is Ca +2, using group number to get charge again. Nitrate, if I look at the table, nitrate is NO3 with a -1 charge. So if I have 1 calcium, I'm going to need 2 nitrates. So I'm going to put that NO3 in parentheses and put the 2 on the outside. So 1 calcium ion, 2 nitrate ions. Potassium sulfate, potassium is K+1. Sulfate, watch your differences, eights versus ites, there's a difference. So sulfate is SO4 with a -2. So here I'm going to need 2 potassiums for every 1 sulfate. Beryllium is in group 2. Phosphite, we have the ITE, is PO3 with a -3 charge. So here I'm going to need 3 berylliums to give me a +6, and I'm going to need 2 phosphates to give me -6. Ammonium chloride, ammonium is NH4 with a +1 charge, down here at the bottom. Chloride is the Cl with a -1 charge. NH4Cl gives us the neutral molecule. One thing to note here, anytime something ends in IDE, with the exception of hydroxide, of course, IDE means you're looking at the elements that are on the periodic table. So that is the chlorine ion. For example, fluoride will be the fluorine ion. Last one, cobalt hydroxide. There should be an E here. Cobalt, if you go back and look at the transition metal table ion, cobalt is a +2. Hydroxide over here is a -1. So that means for every 1 cobalt, I will need 2 hydroxides. Here are a few more examples. This time you're given a formula and you're asked to decide if it is correct as written, and if it's incorrect, then you want to fix it. So we're basically working backwards here. Sodium, group 1 is +1 charge. Sulfur, sulfide ion from the periodic table is a -2. So if, as written, we've got +1, -2, which does not give us neutral, so it is incorrect. We're going to need 2 sodium ions for every 1 sulfide ion. Barium is +2. CO3 is carbonate. If we look here on the table, CO3 has a -2 charge. So +2 with a -2 makes that neutral and correct as written. Potassium's group 1. SO4 is sulfate, which is a -2 charge. And this formula tells me I have 2 of them, so that means there's a -4 altogether. +1 -4 is not neutral, so this one's incorrect. If I'm comparing the +1 and the -2 charge, I actually need 2 potassiums to give us +2 overall. For every 1 sulfate, that is -2. Lithium is in group 1, so it's +1, but there's 3 of them, so that's going to be +3 total. Phosphate, PO4, is a -3, and there's 1 of them, so +3 -3, that's neutral. NH4 is ammonium over here, that's a +1. OH is hydroxide, which is a -1. This tells me I've got 2 of the +1s, so actually it's +2 overall, so that is not correct as written. All we really need is 1 of each, so NH4, OH. This table gives you some more practice with writing ionic compounds. So first I want to show you how to fill out this table if you weren't able to figure it out first. Then I'm going to ask you to pause the video and finish the table, and then you can come back and check your answers. So the way this works is you're going to look at the cations that are in this first column and the anions that are in the first row, and wherever the two meet, you're going to write the formula. So this first box here is going to combine NH4 plus with Cl minus. So I've got 1 of each, so it's just going to be NH4Cl. If I want to look at the second row, I actually don't know what the cation is. It's not given. I do know that the anion is going to be the Cl minus. To get the cation, I'm going to look over here and see that I actually have iron. The question is, what's the charge? So it's telling me I have 3 irons and 2 phosphates. So if I look back at the polyatomic ion table, phosphates is a -3 charge. Here I have 2 of them. So that means it's a total of a -6. The iron, I don't know the charge. It's one of the transition metals, but it tells me I have 3 of them, and I know it has to equal +6 so that I have a neutral compound. So that means that the iron, each individual iron must be +2. So +2 times 3 is +6, -3 times 2 is -6. So that's how you work backwards from a formula to figure out the charge of a transition metal ion. You can also uncross, so the opposite of what we were doing earlier. So this subscript is the charge of the phosphate, which we know from the polyatomic ion table. This subscript becomes the charge of the iron, which is and does match what we just figured out. So what we have here for this row is going to be iron 2+. So if I put iron 2+ with chloride that's a -1, we'll end up with FeCl2. So that's the process for completing this table. Go ahead and pause the video and see if you can finish it up, and then come back and check your answers. Here are the answers. If you need to pause it and take some time to check your answers, go ahead. And hopefully you've got some good practice with writing ionic compound formulas.